All right, caffeine-free conclusion coming up here. Got our molecule copied again. Please, you're going to only draw the molecule one time on the test and put all the labels on the same molecule. Okay? For geometry of each central atom, if an atom is bonded to more than one other atom, it's called a central atom. So hydrogen's never a central atom, is it?
No.
So, yeah. But these carbons are all central atoms here. Every oxygen except two of them are central atoms. These are not central atoms. They only, I mean, no, I know you're saying there's two bonds. Wait, he just said if it has more than one. No, it's got to be bonded to more than one type of atom. More than one other atom is what I'm saying. So it's on the end, a carbonyl O and a carbonyl O. No geometry there. Every other atom has geometry. Not H's, not things sticking off. So I'm just going to go like this. The geometry of this atom here is atom A. And guys, just a reminder, it all comes from hybridization, right? So yeah, if you don't know the hybridizations, and that's easy, right? You count in the sigmas, there's 3. Lone pairs, there's none. Hybridization, sp2. As soon as you've determined it's sp2, write down the bond angle. What are they? Okay, give me the name. What are the bond angles? 120. Every sp2 is always 120. And when there's 3 atoms around that atom and no lone pairs, you can say it again. What's the name of the geometry? Trigonal planar. I'll accept the short form trig planar. And let's go hunt down all the trigonal planar atoms. There's a bunch, aren't there? The C double C's all get the label A. Not the next C. I think I got all the A's. I did. Yeah. We'll go for B. And there'll be a whole bunch of B's, right? What's the hybridization of B? It's got 4 sigma bonds. What's the hybridization of B? sp3. What's the angles for any sp3 ever? 109.5. Now, when there's no lone pairs on that, what's the geometry where there's 4 things around the sp3? Say it again. Tetrahedral. Now let's go hunt down all the tetrahedrals. There's a B here. There's a B here. B, 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 B. And that N is not tetrahedral, is it? Even though it's sp2? We'll come to that when we get to that. I'm going left to right until I'm done. I got some weird tendencies. I don't like to use the letter C because it looks like a carbon. You can use the letter C. I don't care. Okay, for a label, because I got C's everywhere. I'm going to just skip to D. Do not freak out on me.
Do you notice there's not even a single D in the periodic table? Just a DS down.
Dysprosium.
Is the DS down?
Yeah, I found
Yeah, that's the only one.
So now you're going to have me hunting D's. Scandium. I know it's the second letter. Okay. Well, mate. No, scandium's SC. Never mind. I apologize. Yeah, no, I can't go down this rabbit hole. Thanks, though. I am very interested in the periodic table. D, can you tell me what the hybridization is before you give me answers here? sp3, 2 lone pairs, 2 sigma bonds. What's the angle always for sp3? 109.5. Now, when there's 2 lone pairs, that alters the name of the geometry, doesn't it? Yeah. Remember, here's your summary for sp3. 0 lone pairs, tetrahedral. 1 lone pair, pyramidal. 2 lone pairs, bent. There's your 3 stories for sp3. Angle for all 3 of those, 109.5. That's your sp3 angle. And we got a lot of those B's. Where D? Where D? D. Where did I put my first D? Oh, up there. I think there's only 1 more, or 2 more, or 3 more. 3. D, D, D. I picked all the oxygens that had 2 sigmas and 2 lone pairs, right? Oh, I missed one. Where's it? Above the, but wait. Here? No, that's one, not a terminal atom. 2, it's sp2 hybridized. Oh, I'm not going to do geometry for atoms sticking at the, just sticking off or something. D, 109.5, and I said it, I didn't write it. We said bent, right? And left to right, keep moving on. B, here. Is this an E? And this also is an E? What's the hybridization for the E's? SP. No lone pair, so it's linear. I should have asked the bond angle first to be consistent, right? Yeah, there's our 3 bond angles. We got them all on the page now. And then, are we done? Nope. We got a nitrogen for F. And we'll sneak it in here. Also sp3, correct? It's got 1 lone pair and 3 sigma. sp3. Now, if there's 4 atoms, it'd be tetrahedral. Now, here's 3 atoms and 1 lone pair. Pyramidal. And it's sp3. We should always do the geometry, the angle first. We got 3 angles to learn this course, and I think only 5 geometries. Of the 5, we have 4 here, right? 1, 2, 3, 4, 5.
Is there any way you can post an handout with these?
Yeah, they're everywhere. Any lecture note where I talk about this?
No, yeah.
They're already, they exist, and there's probably more than one time that it happens. You're gonna love it. Okay. So it's sp3 it's got 3 sigmas and 1 lone pair. That lone pair pushes those sigmas down, so it's not flat. We call it a pyramid. And then functional groups, we kind of had some answers already on the previous page. I want to do something fancy for functional groups. We got aldehyde here, right? Yeah. And we had ester here. I think we already had those labels down. And somebody, I think it was this young lady here, ether, or was that you? Yeah. It was her, nice. She said ether here. Now you get an ether when you have an O between 2 carbons, but then again you have an ester that has an O between 2 carbons.
Which one is the smelly one?
Esters typically smell fairly pleasant. Ethers don't smell bad, but you know it's not it's kind of overwhelming, it can be. Like diethyl ether, the smell is interesting, but I don't think I want to smell it anymore. If you're getting dizzy. Esters typically smell fruity. The difference between an ether and an ester is that one of the carbons attached to the O in an ester is a carbonyl. In an ether, neither oxygen is a carbonyl, neither one. And this one doesn't have O between 2 C's, it has O between a C and an H. That's an alcohol. And I'm just gonna label it. I'm gonna call it X and X. And over here, I'm gonna say X equals what kind of alcohol? You're supposed to look at the carbon with the OH attached and answer this one question. How many bonds to carbon does it have? 1. So you put primary alcohol. The carbon attached to the OH has only 1 bond to carbon. That's where your primary comes from.
So this ether is an ethyl?
No, that ester is a trimethylaminomethyl, if you want to know.
Okay.
But that is not germane to this discussion at all. I think it's not relevant for what you're supposed to know. And what do we have here? Functional groups. We got our X's called primary alcohols, ester down here. When nitrogen's attached to 3 carbons, you call it tertiary. And none of those carbons is a carbonyl. None of them. It's an amine. And I should have put that a little closer to the nitrogen, right? There you go. If one of those carbons was a carbonyl, you just change the N to a D. It would be called a tertiary amide if any of these 3 was a carbonyl. Okay? I think we got all the functional groups, so we finally finished our first activity. It took more than an hour. No, it took a little less than an hour. Triple activity. 3 for the price of 1.